So this will be part C of number 3 from the 2013 AB and BC exam. It's a non-calculator problem. We've got this table of values to work with, and then in part C here it says use a midpoint sum with 3 subintervals of equal length indicated by that in the table to approximate the value of this expression. Using correct units, explain the meaning of that expression within the context of the problem. Let's actually do the end of this first. Let's try to see if we can determine what the meaning of this 1/6 times the integral 0 to 6 of c of t with respect to t is actually going to represent. So there's this formula that you've probably seen and used a handful of times that computes the average value of a function on a certain interval. The formula for the average value of a function on the interval from a to b is usually specified by 1 over b minus a times the integral from a up to b of the function with respect to the variable that's in the function. So this formula right here is really being applied to the function c on the interval from 0 to 6. So we hopefully recognize this as an average value of c. It does say to use correct units. Let's kind of talk about the units of this for just a second. The units of c are measured in ounces. So the units of this right here are measured in ounces. And then this differential actually has units of time, and time in this case is measured in minutes. So inside the integral we have ounce minutes, and out here this actually has units associated with it too. B minus a are values of the independent variable, and the independent variable here is t. So this 6 actually has units of minutes, so we basically have 1 over minutes times ounces times minutes, so the minutes are going to cancel, and our result is just going to be measured in ounces. So the number of ounces that this expression gives would be the average number of ounces of coffee in the cup at any time t in between 0 and 6. Now we actually want to find that number. So we've taken care of the second piece of this. Now let's focus on the first piece. So it says use a midpoint Riemann sum, 3 subintervals, equal length, indicated by the data in the table to approximate the value. Well, the data in the table and our integral here goes from 0 to 6, right? And if we want to cut the interval from 0 to 6 up into pieces of equal width and use 3 pieces, we're taking something of length 6, dividing it by 3, and the width of each piece is going to be 2. So if I just kind of quickly, if we just try to plot these ordered pairs that the table suggests would be on c of t, we're going to have a point at 0, point at 1, point at 2, point at 3, point at 4, a point at 5, and a point at 6. So we have 0, 0, we have 1, 5.3, we're up to 8.8 at the t value of 2, then we're up to 11.2, and then it's not really growing as quickly here. We have 4, 12.8, 5, 13.8, and then 6, 4.5. Or 14.5. I know my graph isn't 100% accurate, but it should do what we need it to do here. We want to use 3 subintervals of equal length. So we said a few minutes ago that each subinterval was going to have a width of 2. So the first subinterval is going to go from 0 to 2. The next subinterval is going to go from 2 to 4. So this would kind of be the end of my first subinterval. This would be the end of my second subinterval. And then my last subinterval is going to go from 4 to 6. So we have these 3 subintervals of the x-axis, 0 to 2, 2 to 4, 4 to 6, each of width 2. We're supposed to do a midpoint sum. And a midpoint sum is a sum where we add together areas of rectangles. The midpoint of this subinterval is at 1, and the height of the rectangle at 1 would be 5.5, and that is a horrible attempt at drawing that rectangle. Sorry about that. My next rectangle would have a height given by the function value at 3. So the next rectangle would look something like this, and then the last rectangle is going to have its height given by the function value at 5. So it's kind of tricky for me to make this look perfect, so I'm sorry that it looks a little bit sloppy. But really we want to add together the areas of these 3 rectangles. Well, those 3 rectangles are all going to have widths of 2. So if I'm doing the area of them, I'm going to have 2 times the height of the first one plus 2 times the height of the second one plus 2 times the height of the third one. If I just factor 2, the common width, out of each individual area calculation, the height of the first one is coming from c of 1, the midpoint of the first subinterval, so that's 5.3. I'm going to add the area of the second one, and the height of the second one is going to come from the function evaluated at 11.2, and then the third one is going to come from the function evaluated at 5, which is 13.8. If you took a minute to do a little bit of arithmetic here, you'd be able to produce your result. I'm not going to waste your time and do that on screen. I'll come back in just a second with the answer. So the value of this expression is going to be 60.6. That's just the approximation for this integral. Whoops. Just the approximation for this integral. What we still have to do is we still have to multiply this by 1/6. So the value that we're supposed to estimate is going to be 1/6 times this. And if you take 1/6 of 60.6, I think what you get is you get 10.1 ounces. So at any time between 0 and 6, the average number of ounces of coffee in the cup are 10.1 ounces.